It's almost time to go to Mars. And while many of us are very ready to get on with humanity's journey to the Red Planet, our brains might not be as prepared to take that long trip through space. Interplanetary travel comes with a lot of challenges for our brains, including microgravity, radiation, and even differences in light. And we're going to have to learn how to deal with them if we want our astronauts to get to Mars healthy and happy. Now, most days, you don't think about the fact that our bodies are well adapted for gravity here on Earth because of how you cannot escape the gravity here on Earth. But here at home, your body pumps fluids up against gravity all the time to stop any kind of pooling in your feet or legs. Once you take gravity out of the equation, though, your body has to adjust. When astronauts first reach space, their bodies are suddenly pushing all this fluid up, but there's nothing pulling it back down. And you can see the effects of this on astronauts arriving at the ISS. They seem a little puffier in the face. The good news is this problem only lasts a few days before the body figures out how to handle fluids in the absence of gravity. Except for the cerebrospinal fluid, or CSF, which is a clear fluid that delivers nutrients to the brain and removes waste. But in space, instead of distributing itself normally, it seems to pool underneath the cerebellum. Research published in JAMA Neurology looked at the brain scans of 15 astronauts before and after spaceflight. 7 of those astronauts had spent 30 days or more in a space shuttle, and 8 had been on the ISS for over 6 months. They found that this pooling seems to increase pressure within the brain, which squeezes and misshapes both the brain and the eyeballs. Scientists are calling this condition spaceflight-associated Neuro-Ocular syndrome, or SANS for short. We're still in the early days of understanding exactly how these changes are going to affect astronauts on interplanetary journeys, but researchers have noted that that extra pressure on the optic nerve and eyes can cause trouble with near vision. SANS also seems to affect the connection between different brain areas, and that's been associated with difficulties in maintaining balance after landing. Oddly, those connective changes were actually more severe in the brains of astronauts who'd been in microgravity for a shorter amount of time. It seems like with longer exposure to microgravity, things start to go back to normal. That offers a bit of hope that the brain may be able to self-correct given enough time. So maybe SANS is just a temporary symptom of our brains getting used to new gravity conditions, but we'll need to get to the bottom of that before we put humans in interstellar space or Martian gravity for the long term. Another thing we typically take for granted here on Earth is that most radiation from deep space glances off the Earth's magnetic field and leaves us alone. Even out on the ISS, astronauts are mostly protected by this shield. But once we start breaking out of that protective zone on a journey to Mars, radiation is no joke. Deep space radiation is made of atoms that lose their electrons as they fly through space at nearly the speed of light. And it does not give a good gosh darn. It'll tear through your body like tiny bullets. That's bad news for the tissue in your brain. Those microscopic tears lead to dense clumps of proteins called plaques, which are often seen in dementia, and they keep neurons from working together as effectively. It's also bad news for your body, generally speaking. It can cut through DNA, and if that DNA repairs in the wrong way, that can lead to cancer. Even so, as wild as it sounds, a little bit of radiation is an acceptable risk. Right now, NASA sets acceptable limits for radiation based on age. Since the older you are, the smaller the chance that you'll live long enough to get cancer from your previous radiation exposure. But since we're thinking about colonizing Mars, scientists are now looking into how deep space radiation could affect us in the shorter term over the months or years it would take to get to and from Mars. And so far, it looks pretty gnarly. Recent research on mice suggests that chronic low-dose rate neutron radiation, like the kind people would encounter on a journey to Mars, actually slows down signals between neurons. The mice in this study developed problems with learning and memory and showed signs of distress. If the same is true for humans, this suggests that radiation would be super dangerous for astronauts who'd be in pretty bad neurological shape by the time they got to Mars. Shielding against deep space radiation is tricky, though. Research is going to have to focus on developing super effective shielding if we want our astronauts to be functional once they reach Mars. Right now, NASA is exploring shields with high amounts of hydrogen or boron, which are particularly effective at blocking radioactive particles. And if engineers can design a system that generates enough power, we might one day be able to create magnetic force fields around spaceships that direct radiation, just like Earth's magnetic field. field. Right now, though, we're still looking for the right solution. And one of the most relatable problems astronauts deal with is trouble sleeping. And while they certainly do enough work to warrant a good long rest, astronauts actually don't get as much sleep as they should. They sleep 6 hours on average, even with 8.5 hours a day set aside for it. Now, there are a few reasons for this, but the biggest issue, especially when it comes time to go interplanetary, will be light exposure. The astronauts that go to Mars won't have sunrises and sunsets on their journey, and that's a problem when it comes to their circadian rhythm, the internal processes that tell us when to wake up and go to sleep. On Earth, our bodies respond to different frequencies of light over the course of around 24 hours. In particular, blue light, which is strong in the morning, suppresses the sleep hormone melatonin, and that makes us more alert. Without that 24-hour cycle of sunrises and sunsets, astronauts' sleep cycles go haywire, and their quality of sleep takes a hit. This can cause a range of symptoms, including stress, trouble working, and even hallucinations. To combat this, astronauts on the ISS just installed new LED lights that simulate different times of day. And when we blast out of Earth's orbit, a system like this is going to be vital to keeping our astronauts healthy and rested. Minimizing risks to astronauts' well-being while traveling through space is a huge part of our prep for a Mars mission. And though these things are problems, identifying them now means we're in a great position to tackle them early and get ourselves truly ready to become an interplanetary species. Thanks for watching this episode of SciShow Psych. Before you go, I want to tell you about October's SciShow Pin of the Month. Every month, we here at SciShow release a new space-themed pin, and it's your last chance to order your October pin. This one is of Sputnik, humanity's first artificial satellite, and you can only get it this month. Check it out at dftba.com or in the description below.